Imagine traveling to Mars in weeks instead of months, or reaching distant star systems in decades instead of millennia. Nuclear fusion rockets could make this dream a reality. Nuclear fusion, the same process that powers our sun, holds the potential to revolutionize space travel. In this video, we'll break down how nuclear fusion engines work step by step, explore their advantages, and compare how long it would take to reach the Moon, Mars, Alpha Centauri, and even the Andromeda Galaxy using this incredible technology. To understand nuclear fusion rockets, we first need to understand fusion itself. Fusion is the process of combining two light atomic nuclei, like hydrogen, to form a heavier nucleus, such as helium. This reaction releases a tremendous amount of energy, far more than chemical reactions like combustion or even nuclear fission, which splits atoms apart. In stars like our Sun, fusion occurs naturally under immense pressure and heat. On Earth, scientists are working to replicate this process using controlled environments, such as magnetic confinement in tokamaks or inertial confinement with powerful lasers. The energy released by fusion is clean, efficient, and nearly limitless, making it an ideal candidate for propelling spacecraft across the cosmos. Now let's break down how a nuclear fusion engine works. The primary fuel for fusion rockets is isotopes of hydrogen, such as deuterium and tritium, which are relatively abundant on Earth and other celestial bodies like the Moon. At the heart of the engine is the fusion reactor. Inside this core, deuterium and tritium nuclei are heated to extremely high temperatures, creating a plasma, a superheated state of matter where electrons and nuclei are separated. Strong magnetic fields, generated by superconducting magnets, are used to contain and stabilize the plasma. This prevents it from touching the reactor walls and losing energy. When the plasma reaches temperatures of around 100 million degrees Celsius, the nuclei collide with enough force to overcome their natural repulsion, fusing together and releasing energy in the form of heat and charged particles. The charged particles, such as alpha particles, are directed out of the engine through a magnetic nozzle. This creates thrust by expelling the particles at extremely high speeds, pushing the spacecraft forward. Some of the energy generated is used to sustain the reaction, powering the magnets and heating the plasma. This creates a self-sustaining cycle of energy production and propulsion. Fusion rockets offer several key advantages over conventional chemical rockets. For example, fusion releases millions of times more energy per unit of fuel than chemical reactions, meaning a fusion rocket can carry less fuel for longer missions. Or, fusion rockets can achieve much higher exhaust velocities, allowing spacecraft to travel faster than ever before. Fusion produces no greenhouse gases and minimal radioactive waste compared to fission, making it a cleaner option for space exploration. With a nearly limitless energy supply, fusion rockets can support long-term missions to distant destinations without the need for frequent refueling. One of the most exciting aspects of nuclear fusion rockets is how they could drastically cut down travel times to destinations that currently seem impossibly far. Let's break this down with real-world examples to understand just how revolutionary this technology could be. The Moon, our closest celestial neighbor, has been visited before using chemical rockets like the Saturn V, which powered the Apollo missions. It took those rockets about 3 days to reach the Moon. Now, imagine a spacecraft powered by a fusion engine. The immense thrust and efficiency would allow us to make this trip in just 2 to 3 hours, about the same time it takes to fly from New York to Los Angeles. Lunar exploration could become as routine as international flights, enabling frequent cargo deliveries, research missions, and even space tourism. Mars, the red planet, represents humanity's next big leap. Current chemical rockets, like those used by NASA's Perseverance rover, take about 6 to 9 months to reach Mars, depending on planetary alignments. With nuclear fusion rockets, this timeline could shrink dramatically. A fusion-powered spacecraft could make the trip in just 4 to 6 weeks. That's roughly the time it takes for cargo ships to cross the Atlantic Ocean today. Faster travel not only makes missions more efficient, but also reduces risks for astronauts by minimizing their exposure to cosmic radiation during the journey. Alpha Centauri, the closest star system to our own, lies a staggering 4.24 light-years away. Using current chemical rockets, it would take an unimaginable 73,000 years to reach this star system. A nuclear fusion rocket, however, could change the game. Traveling at a fraction of the speed of light, let's say 10% of light speed, a fusion spacecraft could reach Alpha Centauri in just 40 to 50 years. This means a mission launched today could return data within a human lifetime, allowing us to study exoplanets like Proxima b, which lies within Alpha Centauri's habitable zone. Now let's think even bigger. The Andromeda Galaxy, our closest galactic neighbor, located a staggering 2.5 million light-years away. To reach it using current technology would take billions of years, longer than the Earth has existed. With a nuclear fusion rocket capable of traveling at 10% the speed of light, this journey could take hundreds of thousands of years. While this is still far beyond the limits of our lifetimes, it opens the door to imagining robotic probes that could one day study galaxies beyond our own. Despite their promise, nuclear fusion rockets face significant challenges. For example, building a compact and efficient fusion reactor for spacecraft is far more complex than creating one for Earth-based energy production. Also, fusion technology requires substantial investment in research, development, and infrastructure. As we continue to push the boundaries of science and engineering, nuclear fusion could take us to the stars, unlocking the mysteries of the universe and securing humanity's future among the stars. Thanks for staying with us once again.